Welcome back, students. This is the session 14 from the playlist of electrostatic potential and capacitance. And today I have taken one question from the NEET examination. So this question was asked in the NEET examination in 2016 or 17. And the question here is, there is a capacitor which is filled with 4 dielectric material having the dielectric constant of K1, K2, K3 and K4 as shown in this figure. The area of cross section of the this capacitor plate is A, and the separation between the two plates of the capacitor is given as D, and this distance is given as D by 2. That is, this is the partition which is separating this dielectric, having this dielectric constant of K4 with these 3 material. So this distance is D by 2, and this is this width, that is, you can see the separation between the plate is D. So we have to find the equivalent capacitance of this capacitor. So the easiest and the most simplest way of solving this question is that you can divide this dielectric material in 3 parts. So I have divided this dielectric material in 3 parts, and one more thing here, here AB is equal to BC, which is equal to CD. That is, this length is AB is equal to BC and this is equal to CD. So I have divided this lower this dielectric material in 3 parts. Now this part of this dielectric, or you can say this part of the capacitor, is in series with this part of the capacitor. Similarly, this part of the capacitor is in series with this part of the capacitor, and this part of the capacitor is in series with this part of the capacitor. So let us say the capacitance of this one is C1, the capacitance of this part is C2, the capacitance of this part is C3, the capacitance of this part is C4, the capacitance of this part is C5, and the capacitance of this part is C6. Now the dielectric constant of this part will be K4. The dielectric constant of this part will also be K4, because this is the same material. So now here C1 and C4 are in series. So first of all, we will find the value of C1. The C1 is the capacitance of the this part of the capacitor, and this will be equal to what? K1 epsilon naught A upon D. Now the area of cross section of the capacitor plate is A. So for this part of the capacitor, the area will be equal to A by 3. So this will be equal to A by 3, and here this you can say the width of this part of the capacitor is D by 2. So here I will be putting the value of D as D by 2. So this will be equal to D divided by 2. So this 2 will be coming in the numerator. So this is the value of C1 is equal to 2 K1 epsilon naught A divided by 3D. Similarly, C2 will be equal to 2 times K2 epsilon naught A divided by 3D. The value of C3 will be equal to 2 times K3 epsilon naught A upon 3D. The value of C4, this is equal to 2 times K4 epsilon naught A upon 3D. The value of C5, this will be equal to 2 times K4 epsilon naught A upon 3D, and the value of this C6 will be equal to 2 times K4 epsilon naught A upon 3D. Now here C1 and C4, they are in series, so I will be finding the equivalent capacitance of C1 and C4. So let us take the equivalent capacitance of C1 and C4 as C14. This will be equal to 1 divided by C1 plus 1 divided by C4. So if I divide this, so this 1 by C1, the 1 by C1 will be equal to what? This 3D will be coming in the numerator, and this will be equal to 2 times K1 epsilon naught A plus 3D divided by 2 times K4 epsilon naught A. From here, this 3D 2 epsilon naught A is constant. 2 epsilon naught A is constant, so I will be putting 3D epsilon naught A2, yeah, is constant. So I will be getting 1 divided by K1 plus 1 divided by K4, and so this can be written as 3D 2 epsilon naught A in bracket K1 plus K4 divided by K1 K4. Okay, so from here we can say that the equivalent capacitance of this C1 and C4 will be equal to, I will be just writing this value here, that is C14, this will be equal to, so 1 upon C14, this is equal to this, so C14 will be equal to 2 epsilon naught A in bracket K1 K4 divided by 3D K1 plus K4. Okay, so see, the equivalent capacitance of C1 and C4 is equal to 2 times epsilon naught A into K1 K4 divided by 3D K1 plus K4. Now we have to find the equivalent capacitance of this C2 and C5. So these two are also in series. So here in the as we have calculated the value of the equivalent capacitance of C1 and C4, similarly the equivalent capacitance of this C2 and C5, say it is C25, this will be equal to 2 times epsilon naught. I will write it here. That is C25. This is the equivalent capacitance of C2 and C5. So this will be equal to 2 times epsilon naught A, and here this will be equal to K2 K4 divided by 3D, and in bracket it will be equal to K2 plus K4. Similarly, the equivalent capacitance of C3 and C6, say it is C36, this will be equal to 2 times epsilon naught A in bracket K3 K4 divided by 3D in bracket K, this will be K3 plus K4, K2 plus, yeah. Okay, so we have found the equivalent capacitance of C1, C4, C2, C5 and this C3 and C6. Now, these this equivalent capacitance, now these are the three equivalent capacitance. Now, if I draw a diagram here, if I draw a diagram here, means I will be drawing a simplified diagram in which I will be now showing you the how these three equivalent capacitance are connected to each other. So now you can see here these are so this is C14, so this is the equivalent capacitance of C1 and C4, this is C25 and this is C36. So these three capacitors, you can say, they are now connected to each other in parallel. So simply what I have to do is, in order to find the equivalent capacitance of this capacitor, I have to simply now use the formula for calculating the total capacitance in the case of a parallel combination. So here the equivalent capacitance of this capacitor will be equal to equivalent capacitance of this capacitor will be equal to, because these three are in parallel, so simply they will be added up. These three capacitance will be added up, so this will be equal to C14 plus C25 plus C36. Okay? So now simply we have to add it. Now I will be writing these values here, that is C25 is equal to 2 epsilon naught A in bracket K2 K4 divided by 3D K2 plus K4. Okay? And now, so this equivalent capacitance will be equal to this will be equal to C14 C25 plus C36. So from here you can see that this 2 epsilon naught A 3D 2 epsilon naught A divided upon 3D. This is common in all these three capacitance, and so I will be taking this value as common, and in the bracket it will be K1 K4 divided by K1 plus K4 plus K2 K4 divided by K2 plus K4 plus K3 K4 divided by K3 plus K4. So this is the equivalent capacitance of this capacitor, that is, this is equal to 2 epsilon naught A divided by 3D, and in bracket it will be K1 K4 divided by K1 plus K4 plus K2 K4 divided by K2 plus K4 plus K3 K3 K4, that is K3 K4 divided by K3 plus K4. So thank you very much for joining this session, and I hope you have understood the solution of this question. So in the next session I will be coming up with a different type of a question, and preferably the question will be from either from this previous year NEET examination or from this JEE examination. So till then, have a nice day. Bye.